containers are now solving so many different problems throughout the life cycle of software that it's no longer the same thing if you got in early and you maybe tried it 3 years ago or 4 years ago, because we're now celebrating this month the Docker 5th birthday. So every year Docker has this big celebration, all the community or meetups. I think there's 300 of us now. We all get together and have a birthday party, eat some cake.
Welcome back to the show. And today we're going to look at the Docker revolution for Faster ColdFusion and Easier DevOps with Bret Fisher. And we're going to look at the revolution in how we build, ship, and run software using Docker containerization, and some of the key benefits of choosing Docker to deploy your ColdFusion apps. And Bret is going to be speaking at MuraCon in a few weeks. So in particular, we'll focus on the Mura CMS that's written in ColdFusion. But all this stuff applies to any ColdFusion app. And we'll look at some of the downsides to ColdFusion. We'll look at your dev, staging, and production pipeline, how you might set up your local dev environment with Docker best, and some of the tools you can use. We'll mention Docker Compose, and we'll have a talk about some of the basic daily Docker commands that would be really good to know. So a lot more things coming up in this episode. We'll see what we can fit in here, because if you don't know, Bret is a Docker captain, and he is author of one of the most popular Udemy courses on Docker and has some great YouTube videos on setting yourself up in Docker. So he's a real Docker expert, and he loves to give high fives to people. And he's speaking at about 12 conferences, including MuraCon, in the next 3 months. So welcome, Bret.
Thanks for having me. Yes, it is. It should be the Bret World Tour, I believe, at this point. So it's going to be a lot of fun.
Excellent. So tell us a bit about the Docker revolution in, building and deploying and running software.
It's if you're in this industry long enough, you hopefully gain some insight on larger trends in the ecosystem and what, and you start and. I guess that's the nice thing about getting old, is that once you have 20 plus years of experience like I do, you realize you've lived through these huge shifts in IT technology and how we think about building and deploying applications. In the 90s, it was mainframe to PC. I was a part of that fun. In the 2000s, we went to virtual machines. That was a big change, to shift from physical to virtual. And at that time, people were talking about that there's no way that virtual would be a good idea, that virtual machines were going to be super slow and they were going to be painful, and there was all sorts of reasons not to do it. But today, that's the standard. Like you would only do physical in specific cases instead of the other way around. And then we had the cloud shift. That was the big transformation that's still happening. And I think about 3-4 years ago, right when Docker was getting off the ground, and sort of around version 1 time frame, I was using it in my own startup, and I realized, and it sort of hit me like a ton of bricks one day, that this is the next big one. Like, I'm not going to be watching this in this from the sidelines and realize after it all happened that I was just a part of something really cool and changed in the IT. And I sort of set up and thought, well, what if I could be a part of this change? What if I could be a member of this community to help and take this culture shift and technology shift to lots of people? And that's actually kind of how my journey started. And I think that's how a lot of people's journey starts, that they hear about it first. It sounds mythical, right? Like the cloud. We don't really know what the cloud is. And we start to play with some tutorials online. And at first, it's like every new technology, it's probably frustrating, and the concepts are weird and they don't align with your current assessment of how things should be. And eventually, you probably find a benefit, and if something sticks with you and you realize, oh, that's really cool, that's going to help me a lot. And I find that that's happening more and more. 3 years ago, it was a little bit harder for me to convince maybe the average developer to try out Docker, because there was a whole bunch of yeah buts. There was a whole bunch of extra steps or problems or edge cases. And I think each year that we're getting more and more mature in that ecosystem, those are going away. So now we're seeing, in 2018, we're seeing where it's sort of default when I meet a new developer or a new operator, even now, because operators are coming on board to the Docker ecosystem, that they're saying, yeah, I've tried it and we're looking at ways to implement it. Or we're using it already, but we're looking to use it more. And those are the statements, whereas 3 years ago was, what is Docker? And, you know, I keep hearing this word Docker, but I think it's a pair of pants or something like that. So yeah, it's hard to describe anymore what it really does, because containers are now solving so many different problems throughout the life cycle of software that it's no longer the same thing if you got in early and you maybe tried it 3 years ago or 4 years ago, because we're now celebrating this month the Docker 5th birthday. So every year Docker has this big celebration, all the community or meetups. I think there's 300 of us now. We all get together and have a birthday party, eat some cake, do some hacking. And it's hard to believe that it's been 5 years, but over that 5 years, things have gotten so easier to use that you're not able to describe in an elevator pitch the technology behind Docker. You're just able to say, well, it pretty much benefits every part of the life cycle, from creating software to testing it to deploying it to running it to patching it to updating it and then getting rid of it and replacing it with something else. Like that entire life cycle has now have some sort of Docker tool in play there at various stages of maturity, obviously, because nothing's perfect. But yeah, so that's a really long way to answer that question.
That's great. So in a phrase, it's not your father's Docker, to paraphrase a car ad from the 1950s. So let's just drill down into some of the key benefits of using Docker with ColdFusion and Mura or any other software development system.
Yeah, and it's different for you based on where your focus is. If you're a developer that spends most of your day on your local machine writing code, testing code locally, Docker is the first experience you're probably going to have with Docker is using Docker for Mac or Docker for Windows, which are Docker branded products, but products that make it easier for you to run Linux containers on that machine. If you're on a Linux machine as your main OS, you've pretty much solved that problem. You can run Linux containers all day long. It's pretty easy to do by just installing Docker. But on Mac and Windows, we don't have the ability, because a container requires a specific OS kernel to run, because it's not like a VM. A VM just has its own kernel built in. A container removes that layer of abstraction and says, I'm going to run in a confined space, but on the machine OS that I'm running on. So if it's running all Linux containers, which has been what we've known up until recently, and we'll talk about Windows containers later, but up until recently, we really just had the choice of Linux containers. So if you were on a Mac or Windows, you had to get that all set up to work inside a Linux machine, and that is a little painful. And so the Docker for Mac and the Docker for Windows tools have come out in the last year and a half, and now they're in a sort of a stable release cycle. And they do this almost wizardry type approach to creating a tiny little VM in the background that runs Linux that you don't even know about, and runs it transparently, almost like, I call it a mini VM, because the things are super tiny, just 5 or 10 megs of actual OS data. And those little machines even use your local host for when you're doing web-based programming and you want to bring up your app. It'll actually simulate, it does a little bit of fancy routing in the background so that you feel like you're natively coding your app. But what's happening is it's really running in the background a little Linux VM. So that's all abstracted for you in those tools, and that's been the main way. We've got, I'm sure that Docker probably has, I don't know, I'm guessing millions of downloads on that app. I don't have any statistics or anything. But everyone I talk to that's using Docker, that's their first way of getting it. And it sets them up, it gives them a nice little getting started, it gives them a terminal setup, and then Docker just works right out of the box for them. If you're more of a build person, if you're focused on build and engineering in the middle there, where CI and CD comes in, then your part is probably going to be focused around the Docker Compose tool, which is also a huge benefit for local developers. But the build engineers, they particularly care about that because it's a YAML file that allows you to describe your application. And in the world of increasingly using microservices, that's important, because when you have multiple applications that all have to run independently but all be able to communicate, the tools we had before really kind of weren't great. right? Vagrant was okay, but now you're starting up a whole bunch of different VMs. I mean, what if you have 12 microservices? Like, that's actually not a lot nowadays for teams that are going that route. So tools like Docker Compose that come out of the box with Docker for Windows or Docker for Mac, that tool gives you a single file that you can describe your applications, the ports, their names, all the environment variables they need, any config files they might need, basically all that stuff in a very elegant, terse way. Usually my Docker Compose files are less than 100 lines. And that allows you to do a Docker Compose up, which is a one-liner that does, it starts from nothing and then gives you everything you need to develop or test that container. That is usually what a build engineer or a CI/CD person is going to use in their CI/CD platform. So maybe they're using Jenkins or something to test code. And so in certain teams, it's sometimes the CI people that start using Docker first before the local developers that are coding, because the CI environments get so complicated and they get so hard to build and test the code consistently and correctly, that I'm seeing that being a really strong angle for getting them in back and forth.
So for folks who don't know what those acronyms are, CI is continuous integration, where you're continually testing and building and the code automatically using a tool like Jenkins or some of the other build tools. And CD is continuous development, I'm assuming.
Yeah, that's true. It can be continuous deployment.
Deployment. Okay.
Yeah, then that's more the ops side. That's the hat that I like to wear as the ops person. Is that usually happens after your CI. So once your tests are finished and they're good, most of those platforms can help you get your code where you need it to be, right? Because once you've tested it, where's it going to go next? And there's a new concept with Docker that you have to take into account, where one of the big problems that Docker solves for those build engineers, people that are focused on the testing and deployment of software, is that the ways we got software from point A to point B haven't changed a whole lot in the last couple of decades. I mean, since we were doing floppies and tape, it's mostly been a FTP or SCP or some sort of file copy. Maybe we download code directly from Git or GitHub or something, but that hasn't changed a whole lot. And so with Docker, it creates this concept of an image, which is really a package format. And I like to call it sort of the package format of the future. And that allows you to ship your tested and built code and all of its dependencies. That's one of the keys of the magic. All those dependencies in a single bundled. It's actually a tarball, kind of like a zip file in the background, but you don't really see it at that layer. You just see it moving around. It can run around the internet. It can move around your enterprise and your data center. It uses something called a registry to store these packages. And so you can easily move these around and using push and pull concepts similar to what your versioning system like Git might be. And that solves so many fundamental problems around updating software frequently. Because if we all want to get to that eventual goal of agile deployments and being able to have this magic solution that gets software out, weekly or daily, you're gonna have to automate that stuff. And hand typing, on every one of your servers, different commands was always very tedious. So people would write scripts. And the goal with this part of Docker is to get rid of that scripting and make it more of a definition-based approach where we're writing YAML files that describe this and these things just happen automatically in the background. So yeah, that's continuous deployment.
Great. And YAML is some kind of scripting language, yet another something, I don't know.
Yeah, yet another markup language. It's like an easier version of JSON or a much easier version of XML. Yeah.
But that basically defines what your app, what other containers it can talk to. Can your ColdFusion talk to the database? Can it talk to a file store? Those kind of things, and maybe some other configuration stuff. So perhaps we can think of these Docker packages as being kind of like semi-intelligent deployment objects. They sort of know what to do with themselves because they've got all this configuration stuff baked into them. Exactly.
They're like artifacts in that you're taking, It's usually a 1-to-1 ratio, not always, where you have, if you have, let's say you have a web app, that's usually in a single container image. And then if you have a database you need to run, that's usually in a single container image. And you can move those images around either in the public cloud, the private cloud, or in your data center, depending on what image registry you use. And there's lots of them out there. The default one everybody knows about is Docker Hub, that Docker created that first, but there's lots of other, it's a standard. It's sort of, they've created that standard for moving these, how these images work and moving these images around. And so all the other tools you see about in the industry, like Kubernetes or Azure EC or AWS ECS, which is Amazon's Elastic Container Service, and Azure has Azure Container Service. So you see all these terms around the industry about running containers, but the nice thing is in the background, they've all settled on at least a few things. One is that image format and standard for how these packages look and how you move them around, and then how you run them. Now, once we get to higher levels of abstraction and we start talking about orchestration, that's where things aren't quite standardized or at least agreed upon in the industry. And I think as this industry moves forward, we'll see more formalization and maturity in the standards of that. Doesn't mean you shouldn't use those things. It just means that not everyone works, not every tool works with every tool, and you can't just switch tools without some rework involved. But that's one of the goals around containers, and the reason that Docker was even created in the first place was that we had all these proprietary ecosystems developing in the internet. And you know, the founders of Docker, Solomon Hykes, the actual creator of the original project, and they open sourced it, was actually spawned out of a company that was competing with Heroku. And they fundamentally were trying to create, when they open sourced it all, they were creating an open source version of one of these platforms as a service. And so they gave us all this idea of, what if instead of having to choose an Azure or an AWS and get it all into the proprietary information of all these solutions, what if you could run your own and it would work the same way on premise as it could on any cloud? And that's kind of what the vision of how all this is rolling forward in that ecosystem is. How can we be agnostic about where we're at in the cloud or in the data center or wherever we are, and still do these things like create applications, deploy applications, test applications, and then scale them up to many, many different servers all at the same time.
So by putting your code inside Docker containers, you kind of don't really care where it's deployed. It could be on your local development server. It could be on a test server. It could be out on the cloud. It could be being replicated into dozens of copies to deal with scaling. You don't really care because you've dealt with that in the scripting, and all the container magic takes care of it.
Yes, that's the Utopia, right? I mean, there's finer points in the details of all that, of course. I think when you think about your images, they are these sort of discrete units that really what a Docker image is it's a build artifact of all of your app's code and all of those dependencies, including the apt-get dependencies or the composer or whatever your framework package manager is. It's going to include all that stuff. And so this file might actually be kind of big. It might be a gig in size if you have a large application with lots of dependencies. And you're not necessarily storing your databases there. Like, you're not storing the logs and stuff in there. This is more about the application code. And the idea there is that that's running the same way on your local machine as it will in the testing server, as it will in production. And you're literally shipping a copy of that identical SHA-hashed, SHA-1 hashed image. Then that's a way of sort of guaranteeing that it's identical in every location you're putting it. And so and then the systems are all going to be able to behave that way so that you can be certain. And this is a fundamental problem of IT we've had ever since PCs were being used to run software, was how do I ensure the code on the server is exactly the same code with the exact same dependencies and drivers as on my machine? And that's one of the core principles of Docker, is solving that, at least until we create the new problem, which is whatever the next problem is going to be, is to try to solve this problem so we can truly say, you know what, every single one of those files, and if you're on Windows, it's a DLL. If you're on Linux, it's just a binary. Every single one of those files is the exact same bytes on these two systems, so they should, in theory, behave exactly the same way.
So when you go visit the Emerald City of Docker Utopia, you don't ever get any of those bugs where it doesn't work on production, but it did work in development. It always works exactly the same on all the different deployments.
It does. It does in the cases that those things are true. So what I mean by that is you can't make the network in Amazon behave the same way as the network on your machine, or or you can't make. I mean, we all love to think that Linux is just Linux, but when you get down to it, the Linux kernel is really what's running all of this stuff. And now we have these things called Windows containers, which actually run on the Windows kernel. And Microsoft is creating a huge compatibility. They're really sort of winning me over on them, on the Good Samaritan of not trying to create their own standard for the Microsoft platform, but saying, hey, Docker did a good thing. Let's just keep doing what they're doing. So now, not to get too distracted on Microsoft, but now Windows, like Server 2016, actually comes with Docker and a Docker support license built into the Windows operating system. And I don't know that Microsoft's ever done that before. I can't remember when Microsoft shipped an OS and they said, yeah, this third-party product is actually coming with it, and we'll provide support for that third-party product through your technical support contract. I don't think they've ever actually done that, and it just shows the power and the weight of this revolution and how much it caught Microsoft by surprise, and they had to sort of catch up by adopting the Docker way and adopting the Docker standards instead of creating their own.
I guess if Bill Gates was still at Microsoft, there would have been a Docker memo like there was an internet memo.
No Docker. Ago. It will be called Windows something.
It would be called Walker, right? That would be the window. Yes. So we talked about the Docker utopia here. What about the downsides to Docker? Is there a Docker dystopia as well?
Oh, absolutely. Absolutely. There, and of course, the internet's full of it, so it's fun to. It's just like anything. If you want to read the positive, the worst and the best, always go on Twitter. So, Docker, obviously, I think the biggest issue now, when we were talking 2018, so 3 years ago, I would have said, yeah, there's lots of edge cases, and not everything's wonderful. I think in 2018, the biggest barrier and problem is just where to get started and how to adapt and adopt these new fundamental concepts. I have a course on Docker. You mentioned it earlier, and one of the biggest challenges for I've had over 43,000 students now, and one of the big challenges I can see out of all of them is that it's a huge shift. It's the same mental shift that we all had to make when someone tried to explain a virtual machine to us, and we were saying, wait, you're saying it's an operating system inside an operating system? I mean, does it have its own network card? We were all back then like really kind of blown away by that concept. But that is, I think, the biggest first hurdle that any person or team would come up against is like, how do we educate ourselves so we all understand the same concept, and agree on it? But I think some of the negatives are once we get to those higher levels of abstraction, like we talked about cluster orchestration for production servers. And that is still, well, first off, there's it seems like the winner, if there is going to be a winner, would be Kubernetes. The Kubernetes solution is a great open source project, but it wasn't designed to be run by a part-time end user, right? It was meant, it's sort of a system to make systems with. And so that's why you see a lot of the vendors, AWS and Azure and everyone else, that's why we see them creating tools and platforms to run Kubernetes for you, because Kubernetes, at least to run it securely and fast and highly available in production, it takes a lot of work. So hopefully the industry is going to help solve that problem, because I think if we're all going to use containers, we all want to save time, not increase burden, right? We want to reduce tools, not increase tools. We want to speed up our path from code to production, not lengthen it, right? Those are all the sort of the core principles. So I think when we get to that production part, that's going to be the last sort of area where a lot of the nuances are worked out. And a lot of the consultancies, you know, if you're as a consultant, I always look at where are the consultants all being hired to help teams with. And I think the two biggest areas that teams are always asking for help with are how do we get started and ramp up our team on just our first project because we don't even know what we need to know. And then how do we get this working well in production as reliably as our old infrastructure that it's replacing? And I think those two ends of the spectrum are the big friction points for people.
Mm. So how many months or years before those issues have gone away, do you think?
Well, so for the first one, I think I don't think it's a matter of if you're going to learn what containers are or if you're going to learn how containers work. It's kind of like virtualization, and you know, years before that we had the cloud. It's not a matter of if; it's just when you learn how to create your first server in the cloud. It's just a matter of when you're going to eventually learn how to run some code in a container. And so I think that we will all naturally get there, even if you're in a laggard industry or if you're maybe you're in a government job where, I mean, I've consulted for government, so I have sympathy with the struggles that they have, that you've got 50,000 users that are all inside an enterprise. You're not even thinking about containers yet, probably. So once you've done that learning, I think we'll get past all of that. And, 5 years from now, 10 years from now, we won't be having Docker 101 talks the same way we're having them today. The second one being production, I don't know. I hope that we don't end up in a situation where we have it today, where we have all these tools, we have all these layers of abstraction that we've created, like orchestrators and scheduling and whatnot. But fundamentally, it's no easier for the average person to run something in production than it was before. Like if we haven't solved that, when I say the average person, what I mean is someone who codes and operates for a living and doesn't teach Docker, because I'm definitely not that person. And that someone who they're not a single person running 1,000 servers, right? Because I think we all love to go to conferences and hear the Google talks and the Netflix talks, and we hear these wondrous tales about things called Chaos Monkey, and that will go and wreak havoc to test our outage and our failure rates, and and all these wonderful tools. But there's a lot of us, I think, day to day that are running applications running on 3 servers and running on 10 servers. And, we might have 500 apps like that, but they're not all running 1,000 servers each app. And I think that's a different kind of problem. So I really hope what we get to at the end of the day is, I'm a fan of Swarm. So if you're going to look into Docker and you're considering orchestration, Swarm is one of those options. Docker created it and really focused a lot on the user experience. So I find that it's a great, if nothing but a teaching tool to help someone new that needs to run something on a server and they want to run it in Docker, to understand how can I take 3 servers and treat them like one? Because that's really, at the end of the day, if we're going to talk about orchestration and production containers, we're saying, I want multiple servers to act like one so that I can administrate and schedule my work as if it was as easy as my local machine. And that's what all these tools are starting to do for us. And I like Swarm because it's simple to use, it scales well, and it solves most problems for most people. It just doesn't happen to be the most popular one. So, but Kubernetes does solve a lot of those edge cases and other platform problems that people are, especially in larger enterprises, might come up against. So.
And, I think Portainer is one of the other ones, right?
Yeah, Portainer is cool. It's one of those projects. We joke that there's a new in the container ecosystem. There's a new project every day. So I recommend you always check the GitHub likes. It's not an indicator of quality, but it is at least an indicator of whether it's been around more than a week. But Portainer is a really great tool for managing a swarm. It actually runs on top of Swarm and gives you a great GUI and extra features out of the box. Basically like a web administrative console for a multi-server Swarm cloud, Swarm container cluster. There are other tools out there like Rancher that do similar things. And then, of course, all the cloud vendors are creating their own solutions for that. There's actually a great diagram that if you're new to container ecosystem and you're not even familiar with even the names of these products or these companies, because the new ecosystem and the new startup space for this is a little daunting to deal with. It's like we had with the startups in the late 90s. It was like every day there was a new startup, a new company that existed to serve our pets food or something. And now the same thing is true of the container ecosystem. So there's a organization called the CNCF, the Cloud Native Computing Foundation, and they have a document we can put in the show notes. It's actually a diagram that at least gives you logos and blocks them into groups so that you understand what are the security companies that are doing security stuff in containers, or what are the companies that are working on production orchestration, or what are the companies doing CI and CD with containers? Because once you start doing containers, you realize some of your other tools might have to change as well, and then you don't know where to look. So you get this problem of Googling, and then there's 1,000 options. So they have a nice diagram I'll throw in there. Send you.
Great, thanks for that. So what is maybe you can just tell us what the ideal pipeline is going from development, staging to production if you're living in Docker Utopia?
Yeah. So ideally you're using, you're on your local machine and you're developing with Docker for Mac, Docker for Windows, or on Linux, you're just using native Docker. And pro tip there is to always go to store.docker.com to download and get the correct install instructions for Docker, because especially if you're on Linux, and it's also almost as complicated depending on what Windows version you're on. Mac is pretty cut and dry. But on Linux distributions, it's different per distribution because of the different package managers. And on Windows, it's different per version of Windows because Microsoft and Docker are really making it the best on Windows 10. And unfortunately, only on certain editions of Windows 10, which are Pro and Enterprise. And so depending on what version of Windows and edition of Windows, you might have different ways of installing it. So I have some YouTube videos on the nuances of all that. So that's sort of the 101 getting installed. I can send you the YouTube video links. And so that's the first step. Once you're doing that, then you're probably going to be wanting every day, all day, as you're developing, to use the Docker Compose command line. My expectation for a developer team is that once they adopt Docker, that the average developer is using Docker Compose up and Docker Compose down and other Docker Compose commands to replace all their other environment setups. If you were traditionally running on Apache and you were starting an Apache server, or if you had to start your own little MySQL server locally, or your own VirtualBox, or your own Vagrant, all those different tools we used to have, those are all replaced by Docker and Docker Compose. And the Docker Compose command line was designed for local developers to make their workflow buttery smooth. So they're doing that. Then you put your code in your code committing solution, whether it's GitHub or Bitbucket or Team Foundation server or whatever place you store your code. Hopefully it's in a versioning system. And it doesn't have to be there, obviously, but in a team environment, I'm assuming that it is in some sort of versioning system. So that system is going to probably talk to your CI solution. And the nice thing is Docker's been around long enough that at this point, every CI solution has accounted for Docker. So the good news is whatever you're doing today for continuous integration almost certainly works with Docker, because it's now the 800-pound gorilla. So everybody's trying to update their tooling to work with Docker, right? That's a nice thing. So now you're going to be testing those images, because the goal is that you're doing continuous testing, and that the images make it really easy. So what your CI tool is going to do is it's going to pull down that code, and it's going to build what we call build the image. It's going to actually install all the dependencies in that image and make it. And then it's going to do the testing on the image itself. So whatever your prior unit testing was, or whatever you were doing, that's all going to just now occur the same way, but it's going to be in the container, which is great. Because when you do it in the container and it works and you get all greens back, essentially, that image is now sort of, you've now accredited, or to the sort of speak, that image. And you can then push that image up to a registry and store it. Now, once it's in that registry, which is really just, a registry is really just a HTTP web service that stores data. It's a very simple solution that uses HTTP calls to let you push and pull these images. So once you put that image there, the world is your oyster, because you can decide that you now want those images to run on servers somewhere else. Maybe those servers are in the cloud, maybe they're in your data center. And as long as those servers can talk to that registry, they can pull down your images or any old version of your images, which is a vital component of all this, is that it keeps all those versions and it keeps them over time, and it's nice and smart. So it's only going to store the differences. So you're not going to have these huge bloated packages. It's got a nice differencing system and built in, so that if you only changed one file of code, then the registry is only going to store one file of change in the storage system. So your storage is going to be nice and efficient. And you'll pull all those down to your servers and run them. And then if you need to go to an old version, it'll pull down the old version and run it. And there's a concept in Docker called tags, and that's how we label these images. And you might label one version 10 or version 2018.03.22 or whatever. You might version via a commit ID, because that's how you version your software. So those things all become what we call tags, and you would download the specific tagged image and run it wherever you need it. Now it comes full circle. So that image can now be downloaded by developers locally on their machine and then tested or coded against in their local machine when they're developing. So the nice thing is if you're in a team environment and you have many different containers, and maybe you're working on the API, but someone else develops the web front end, you can now download their image as a part of your Docker Compose and run their image while you're developing on your image of the API backend. And it allows you to easily change out versions by just changing one line in that Compose file. And then what Docker will do is suddenly download a new version of your dependencies or a new version of someone else's image. And once you get that full lifecycle in there, it really becomes a nice story around everybody is using everyone else's images, everybody's pushing their code into images, and the image becomes that sort of key way of running and testing containers.
So what would you say to someone who's like, I get how this helps the DevOps guys have an easier life, but I've got a developer team here. We've got like a dozen developers. How's this going to make our life easier? It sounds like a lot of extra work. Why can't we just develop on our local machine and be done with it? You know?
Right. You're right. Well, and you certainly can. The goal of Docker, one of the goals is that the code that you're writing operates the same in dev and in test and in prod. And in order for us to get closer to that goal, you need to be able to run the code locally while you're developing it. That code should be running on a similar OS and kernel that you're going to be using in production. So using something like Docker Compose, and I would say that the hard part about all this for a new developer, besides just conceptually getting over the conceptions of what a container is and what an image is and how they work together, and then writing your first Docker file, and that Docker file is your instructions of how to build your app. So you probably already have your build instructions. They're probably in a shell script or in some sort of package manager commands already. So you're really going to just be transferring those into the Docker file format, and then you're going to create a Compose file to go along with it. The Compose file is not required, but it does make starting multiple containers easier, so I always recommend it. And those two very small files, I mean, the average project is usually less than a couple hundred lines on each file. And that information is information you already had today. You just have to kind of get over the learning process of how does it expect that information to be in here. Because it's going to store your environment variables, it's going to store your passwords, it's going to store all that stuff. And so once you've done that, what it does for you as a developer in a team is it allows you to use those single Docker Compose commands, like Docker Compose up, Docker Compose down, to literally tear down and create entirely new environments in one-liners. And so if someone else on your team creates a new project and they're testing in a new version of ColdFusion, and it's got a new version of this Bower dependency for some front-end thing, you don't have to worry about any changes on your system to be able to run both at the same time, because these are all isolated, discrete units. None of them have the chance of interfering with each other. So now I'm able to run one Docker Compose well, I've got a MySQL version, 8.0, and I've got this version of Python running, and all that stuff's in those images and running in my containers. And then at the same time, I could be hitting it. Maybe I need to test these two different things together, and I could be using some other code that I'm running, and in its container, it's running an incompatible version of Python or a totally different version of MySQL, and they all get their own IP addresses. They're all operating on the same network, and Docker takes care of the DNS for you. It does the private networking part. It sets all that up for free. You don't have to do anything out of the box for that to work. And so when I start showing that workflow to developers, and I'm like, okay, take that 12-page document you had for a new developer that describes all the steps installed to get their environment set up, just to write a line of code, and take that out, and now you're left with a paragraph. And the paragraph is git clone, somehow get your code on the box, whether it's git clone or what other SVN you're using, and then Docker compose up. Well, I guess maybe the first step would be install Docker, which is sort of a GUI. In Mac and Windows, at least it is. So you've installed Docker, you've cloned down your code, and ideally, if you set a standard in your team, each repository has its own Docker file, and then each solution, if you have a web front end, an API, and a database backend, that's a three-tier solution. So that solution would have one compose file. And so ideally, you have that one file, and it's in an easy place. It's probably in the root of one of the repositories. And they just type Docker compose up, it finds that file, and then wait 30 seconds for everything to magically download and start up. And then what you're left with is then what it starts to do by default is it'll start listing all of the logs combined from all the different systems and colorize them for you from all the different containers in a nice, pretty way. And then all the ports are open, and you can go just open up your apps in the local host like you're used to, and open up your developer environment and start coding like you used to. But it's all actually running in this tiny VM in the background that you don't even realize. And so when I show that to a developer nowadays, it usually clicks for them. They usually go, wow, that's so much easier than all those Vagrant files and all that 12-page document we used to have for developer setup.
It does sound a lot easier. Now, just one small thing here. ColdFusion can run on Windows or Unix or Mac, but if you're using it in Docker, you basically are running the Unix flavor of ColdFusion. Is that right? Or?
That's correct.
Yeah.
And on Windows, it gets a little more nuanced, because now that we have Windows containers, when you're on Docker for Windows and you're on Windows 10 Pro or Enterprise, because this is their latest generation of tech, right? Microsoft's doing some really great innovation. So if you want to be, let's say you're running ColdFusion on Windows servers in production, you can now be doing that development. You can now do that development. Let me correct my English there. You can now operate there locally and run the ColdFusion EXE version, the Windows binary version, and have your code operate against that, because that's what you might be using in production, not a Linux server. So it's not that it's not that Docker is a Linux specific tool. It was at first. That was the first OS they tried it on. But nowadays we see it running on IBM Z mainframes, Solaris. It's running on lots of different platforms. Mac is one of the few left where Apple doesn't really have an answer, so they're not trying to make the Mac kernel run Mac apps in a Docker container. And maybe that might be a thing someday. I haven't heard anything, but as far as I know, they're not. So Windows is kind of the best of both worlds, because on Mac, I can't, unless I run a virtual machine with Windows on it, I can't run a Windows kernel. But on a Windows machine with Docker for Windows, you can now, there's a little toggle box. It'll give you a little option. Do you want to run Linux containers or do you want to run Windows containers? And if you're running ColdFusion code, you can choose which one of those binaries it would run against. And then obviously when you build your images, what you do is when you're building those images, you specify the kernel that it comes from. So on Linux, it would maybe come from a Debian distribution or Ubuntu distribution, because sometimes in Linux you want that base layer of package manager so that you can install all the proper tooling you need for your app, right? But on Windows, you might need IIS and other tools to run. So that's what the Windows Docker file would use, is you would base it on .NET Core version 1.0 or whatever you might need.
And then when you deploy that out to Amazon Cloud, you can still have it running the Windows kernel.
Right. Right.
So,
On Windows, the support structure there is Windows Server 2016 or newer. And I think they just announced Windows Server 2019, and they're claiming it's going to be even better with containers. But the story with Windows 2016 was around 2014, 2015. Microsoft actually, Windows 10 had already launched. So Windows 10 didn't come natively out of the box with Docker support. It had to be bolted on through later packages or updates. And so that was actually the first case where I'd ever seen Microsoft in the middle of an operating system release take the Windows kernel and completely add new functionality to it to support Docker. On Windows Server 2016, they did that before they launched the OS so that it would support Docker containers natively for Windows containers. So yeah, so you can run a Windows container, the latest version of Windows SQL or Microsoft SQL runs natively in a container on a Windows server without any sort of VM in the middle running Linux or anything. Yeah, so it's pretty cool.
So you mentioned there are a lot of tools. Tell us some of the top tools that we should know about for Docker, both for devs and DevOps.
Sure. So you have your Docker specific tooling. And so we've talked about the Docker for Windows, Docker for Mac, and then we talked about Docker Compose, and that comes with those. It's kind of built in, but it is a separate tool that's an optional tool you don't have to use, but I highly recommend it. The next tool there is Docker Machine. And Docker Machine, it's actually Docker dash machine from the command line. So if you have Docker for Windows or Docker Mac installed, you'll also have that tool. And that one is for managing, what it actually does is it manages virtual machines. But it doesn't just manage local virtual machines. It allows you to create cloud machines. So you can actually give it your DigitalOcean code, your Azure, your AWS codes, your API codes. And it will, in a one-line command, like Docker Machine, create VM1, and it will go and create based on either environment variables you set or options you set in the command line. It'll go create those machines and then automatically install Docker for you. Now, Docker is really not hard to install, especially on Linux. But what this does is this helps you, it gives you a nice little command line GUI so that you can have multiple ones of them. And then one of the native things you get out of the box with Docker is by default, it's a command line and server separation of powers. So when you run the Docker command line, you're actually using the CLI binary. You're not running the actual server. The server runs on whatever system you're pointing to. And it's a subtle little nuance that most people don't pick up when they're starting to use it because it just works against your local machine by default. But what's actually happening is Docker's running as that service or daemon in the background. And that's the Docker D. And so the cool thing about Docker Machine is it allows you to very easily set up either virtual machines locally or in the cloud or on other systems. And then with another line, it's actually called Docker Machine env, you can change your local Docker CLI to speak to that server securely over TLS. And what that now means is that you can be local using your Docker commands and your Docker Compose commands, but you're actually running it and pushing the code to the server that it's talking to. And that might be on the internet or in your data center. So that's a really neat tool to use. It's not necessarily a production-like tool, but it's really great for dev and test where you're just wanting to spin up quick little things and run code on them in a Docker fashion.
So as a developer, you've now got superpowers to be able to spin up containers, anywhere in the cloud that you've paid for. Yeah,
and it's sort of a 1, 2, 3 punch kind of thing. They're all command line driven. Unfortunately, there is a GUI called that comes bundled sometimes, and sometimes you can download from Docker. I think it's called Git Medic. I haven't used it in a couple of years, so it still gets updates, but it's not really been heavily adopted. So I'm not sure that, especially for developers, it was really meant for almost like an end user tool. Say that an end user wanted to run a MySQL database locally for some reason. They could use this GUI to sort of point and click, and it would actually download Docker MySQL container and run it in the background. So it was a really interesting concept, but I think that really hasn't caught on yet. You can't really one of the things with Docker is we don't really have an easy way to run GUI-based applications locally on like a desktop machine or laptop. So you can't run Chrome with the browser GUI in Docker without a whole lot of hacking. So it's not for the faint of heart. So, but once you get past the Docker tools, and I mentioned Swarm earlier, but that's built into Docker. So if you're interested in container orchestration, check out Swarm. It's built into every version of Docker. And then after that, you suddenly find that whatever your cloud vendor is, or whatever the tooling you already have for your continuous integration, your continuous deployment, maybe your server manager, even VMware, if you're involved at all with any of that stuff, all those companies have their own existing Docker solutions. So I usually recommend to teams that before going and surveying the entire landscape of hundreds of different tools and getting lost in that sea of tools, look at the stuff you already have, the stuff that you already know and invested time in, and see if they already don't have better tools to help solve some of your problems. Most CI vendors have a lot of Docker documentation to make it easier for you to adopt building and testing Docker containers. So that's great, because none of us want to go change our CI tooling just because there's a new tool in our pipeline. There's a really great, another link that we can add to the show notes. It's called Awesome Docker. And if you just Google Awesome Docker, it's a list on GitHub, a community-driven link list. It reminds me of Yahoo in the 90s. If you ever did Yahoo in the 90s, where it was a community-driven aggregated list of links to other places on the internet, that's essentially what this is. And it's everything from training to local testing tools to GUIs for managing your servers to just about anything you can think of in the container ecosystem. They have them linked there. And the nice thing is that they use emojis to indicate that this is either maybe a buggy like new thing that you might not want to use, or this is a dead project and they put skull and crossbones on it, so you know that, because on the internet things live forever. So then you go to a website, you don't realize that this has happened, that company folded, and the only way you know is that there's a blog post hidden somewhere in their blog that says, we're not really doing anything anymore, but we still exist as a website. So that's a really great list I like to recommend to people.
That's a great resource. So we'll put that on the show notes at the TerraTech site. So you mentioned that cloud vendors have Docker tools. I want to ask, what's your favorite cloud vendor based on how great their Docker tools are?
Ooh, that's a good one. Well, I think it was so early days for all the cloud vendors. I don't think that I have favorites for specific situations. I have to figure out how to make a universal favorite. I love DigitalOcean for its simplicity, and it doesn't have necessarily the only thing that really Docker has related to DigitalOcean is when you go to DigitalOcean, it has I can't think of the name of what they call it, but basically when you're choosing what server you want to run, you can choose apps. So you can run, Mura CMS or some other product, and one of them option is Docker. So it'll have Docker pre-installed. So that's great, right? It saves you 10 minutes and having to go look up the tutorial on how to install Docker. So that's nice for DigitalOcean. But I love DigitalOcean mostly because it works really well with the Docker machine out of the box. So Docker machine has a driver for DigitalOcean, just like it has a driver for AWS. And for small projects, personal things that I'm doing, or community-driven stuff, I work with Code for America that we basically take citizens and around our physical area, and we all get together and we hack on social projects locally trying to benefit the community. And I use DigitalOcean for them heavily because everyone understands it. It's super easy to get started. You're not going to get overly overwhelmed. And Docker makes it really easy with the Docker machine tools there. So with AWS came out really early with something they called ECS, Elastic Container Service. And if you're someone who's tried and true AWS fan, and you do CloudFormation templates, you have EC2 server instances, and you use their RDS databases, and they love their acronyms over there. Even AWS itself is an acronym, so they love their acronyms at Amazon, and they have now 3 different options for how to deploy Docker. And the original one, and probably still the easiest one to get started with, is called ECS. And so if you're someone who in your company, in order to use a tool, it needs to be compatible with AWS, and that's a real thing, right? Where teams are, especially ops teams that are pretty strict, they might say, this has really got to run easy on Amazon, or we're not going to do it. So look at ECS, because that'll fit right inside that AWS tooling you already have. It works with the AWS command line tools. and it uses the logging in AWS instead of the Docker logs. It uses the built-in logging of Amazon, but Microsoft's innovating over there on their container platform. They have the Azure Container Service, ACS, I believe. I'm not going to use that acronym. They just call it Container Service. And the nice thing there is that they actually have a really cool command line in the cloud feature, so that you can actually, and you probably know this if you're someone who's ever used Azure, it's not just for Docker, but you can use it with Docker, and it basically gives you a shell in a browser that you can use on your servers, even PowerShell if you're on Windows servers. And because the Docker tooling is often a command line driven thing, that makes it easier for you to do stuff from anywhere. Even if you're not at your own machine, you can just log in somewhere else, have that command line in the browser. And that's a pretty neat thing that I'm pretty sure they're the only ones doing, at least of the major cloud platforms. So I don't know. Everyone's got their own, their little spin on it.
Great. So I also want to mention Command Box, which is a ColdFusion tool that's open source that, makes it very easy to get, create new ColdFusion instances in Docker. So
cool.
That's another one. I was talking with the evangelist for Command Box, Brad Wood, on the podcast a few weeks ago, and I'll link in his episode on that. But there's a lot of cool things happening with ColdFusion and Docker. So
yeah, I mean, the container technology world is so exciting, and I think it's really pulling a lot of the energy out of people that are dedicating time to open source and to focusing on the community. You see a lot of that moving towards container tooling because it's like the wild, wild west nowadays. it's where all the fun and exciting things are happening in all the different ecosystems of programming, I think. And obviously, we've got things like drones and all sorts of IoT device stuff. But the nice thing is that Docker works really well in those environments too. So it's one of those things where it's hard nowadays to find an ecosystem or even a use case where Docker is not going to benefit the use case. I fully expect my car and my refrigerator to be running some form of Docker in the future. DockerCon is an event we have every year. This year it's in San Francisco. It's one of my favorite conferences of the year. And it's in June in San Francisco. In the EU, it's in December this year in Spain. And one of the best demos I ever saw was they brought out a military grade quadcopter drone, and they flew it on stage, and they updated the operating system while it was flying with Docker to a new version. And then they showed all the performance stats on screen while they were doing it. So they were trying to make sure we believe that it wasn't like the key with DockerCon is always that all demos have to be live and the riskier the demo is, the more likely you're going to get on stage. So they were flying it, and I was kind of hoping they'd fly it over the crowd to up the ante a little bit, but they let it hover in the air and they updated and replaced the OS while without it even having a hiccup. And they talked about that they have now drones that are in the air so long that they need to be able to patch them specifically for security because now we're getting drone hacks attempts. And they were talking how Docker is allowing them to replace their code in real time without and lowering the risk of them having failures while the drones are in the middle of the clouds, literal clouds, not the virtual cloud. So
wow.
that was a really cool one.
That is cool. Yeah, I mean, I don't think we have time to go into security, but when I was talking to Neil Creswell from Portainer, he was saying that, there are crypto hackers that, will try and take over your Docker swarm and, stick their own Bitcoin generating code into your containers and use up your Amazon credits while they make off with a whole bunch of Bitcoin booty. So,
yeah. That's happening everywhere, and it's not just containers. I have a good friend that works at one of the major cloud CI companies that you can put your code up there and they will process it, right? And if you think about it, those continuous integration solutions on the internet are basically just big farms of servers doing work. And one of their biggest struggles, she says, is that the hackers aren't trying to hack through the servers; they just want to mine. So they're constantly having to detect CPU spikes and different mining activities that to block out these accounts, because a lot of these solutions nowadays, they gave you a free account or whatever for 30 days or something.
Oh.
They're signing up with all these free accounts, getting in, and 30 days of free mining is fantastic if you're a Bitcoin miner. So yeah, I think that's happening all over the landscape. It's Docker's just probably making it easier for them once they are able to hack it. And I think the news on that was actually that was Kubernetes by default doesn't secure the web portal. And yeah, I keep hearing news about that once that's anything on the internet that should have a password. And I don't know why we keep doing that, but evidently companies keep doing it, thinking that no one's going to find it. So
yeah, there's no anonymity in the internet. So
yeah, exactly.
So you're a Docker captain. You've been using Docker for many years, probably in Docker years. 5 years old is like several lifetimes of human years, I imagine.
Right.
So tell us why are you proud to use Docker?
Well, it first solved my own problems. I had a startup that we ended up failing as a startup, but our tech was awesome, which is a classic problem. Focusing on tech, not customers. But we used, we were actually, that's how I got my first start with Docker, was using it to solve our own CI and CD problems. And it was rough days back then. It was not near as smooth as it is now. And I'm proud now for many more reasons than just that the tech is good. It's because the more I get involved with the community, and this is more of the larger container community, not just the Docker community, although especially the Docker community. It's the most friendly, accepting, diverse group of people that I've ever worked with, and it has transformed my my career and I was a freelance, so I have my own company. It's transformed the way I do my company. The people I engage with and work with on a daily basis are now all container ecosystem people, and it's great. It is to the point now where it's almost like going to family reunions at the conferences. And these are vendor conferences. I mean, DockerCon is technically a vendor conference. And normally you don't get that at a vendor conference. And normally you have to go to community conferences for that sort of intimacy and community sort of focus on the people and not on the products. And I continue to get that feeling, whether it's the Docker meetups that I go to. I also run one of my own here, a small one, and trying to create that a place where it's easy to learn. It's okay to be new at it because everyone's pretty new at Docker. So we don't have anyone in the community that's some old stodgy person saying, "Oh, I can't believe you're here asking about what's new because everyone should know this by now." We don't have any of that. And hopefully we'll never will, right? It's a community, I think, that's of people that are excited about the new horizons. So I go to events for nonprofits, and sometimes at events like DockerCon and some of the other community events for containers, it feels almost like one of those where everyone is there with the same purpose of making their little chunk of the world better through this neat technology innovation, and trying to make their work lives more enjoyable, and meeting good people and trying to work together to solve problems. So I think that overshadows now my excitement around the technology, and so that's why I'm probably talking about Docker 12 times in the next 3 months. Is not only because I can't say no, is because I love the community. And at every one of these events, I'm going to see someone that I know that I've seen at a previous event that I want to catch up with and I miss, and want to see what they're doing. And it's a good opportunity as any to travel around the world and talk to people. So
great. So it sounds like the Docker community is really alive. So what would it take to make Docker even more alive this year?
The stretch goal for 2018. I think that the community has to, like every new community, especially in open source, it starts out as an open source project and everything's free and wonderful and we're all holding hands singing Kumbaya. And then because the world is the world that we've invented, we've all got to go make money on it. And so now there's a huge bit, for the last 3 or 4 years, there's been this huge land grab of every company It has their own spin, their own new startup, their own product. And what I think we as the community have to do is not so much do better, because I don't think there's a problem yet, but I think we have to be very careful to not turn into a vendor conference or a vendor community where it's really just pitching a bunch of products and there's more marketing people there than there are technical people. You know, the great thing about a Docker community conference or a DockerCon or a KubeCon or a CNCF conference or a Cloud Conf from Linux Summit, there's all these different conferences about containers, is that all the ones I go to, engineers are everywhere. Engineers are the ones talking about the products that they're creating. Engineers are the ones implementing the products they're creating. There might be some sales and marketing people there and maybe some project managers, and not that those people are bad, but the community started as a developer community for people helping people. And if we get away from that into this, well, it's really just corporations selling to other corporations and the engineers are just a tool to get us there. There are lots of conferences like that already. We don't need more of those. We don't need another community like that. And what I'm nervous is that we're going to, once, San Francisco and the startup community gets their hands on it like they love to, that we're going to end up in that world. And so I hope a lot of us in the community leaders just sort of dig in and keep sort of doubling down on our commitment to the community and leading people, not product. I don't know, I should make that like a tagline or something. People, not product. And focusing on helping people help themselves and their own jobs and their own teams. So
great. So what are you looking forward to at MuraCon in a few weeks?
So that's exciting. I have family in Sacramento, so I've been to Sacramento. I was there in the Navy, actually, in the 90s. It's a cool city. I haven't been back there since. I'm glad to be invited to be there. And we're going to be covering everything from a workshop on Docker 101 for ColdFusion developers. And then during that workshop, we're going to actually add in a little thing at the end around how to specifically use the Mura CMS and help people get up started and using a real world example of a application on their local machine using Compose and using Docker, and regardless of what operating system they're running. And we're going to start there with a workshop, and then I think I'm going to finish up with a talk on production, and we're going to talk about the journey that most teams need to make on taking their Docker containers and how do I get those working on my server so I get that full lifecycle benefit. And we'll go through some examples, lessons learned, and I actually get into technicals. I show example configs. It's not just a project talk about all the wonderful project plans. It's more of a hey, if you're going to make operating system decisions, this is what you need to consider. If you're going to need to worry about what type of applications to run, this is what you're going to consider. So if you can't make it to MuraCon, I'd love to see anyone there, especially if you've listened to this podcast. Definitely stop by my session, bug me in the hallway. I'll be there both days, all hanging out. But if you can't make it, the talk, if the MuraCon talk isn't going to be available, I have similar versions of that talk and that workshop that others actually give, because this is an open source community. So all the talks and everything I give are all open source. We keep all the content online, and others share the content with me, so we all feed off of each other's best practices and understanding. So I'll make sure that reach out to me either on Twitter or through the show notes, and I'll make sure you get the links to any of that stuff if you can't make it to MuraCon.
Great. So if people want to find you online, what are the best ways to do that?
Twitter and my website. So I'm Bret Fisher on Twitter. That's 1 T and no C. So it's BRETFISHER. And then BretFisher.com, spelled the same way. I have a bunch of resources there. Common problems with Docker. I actually have a Docker AMA there where you can reach out and ask me questions on GitHub as a GitHub issue, and I will close your issue by hopefully having a solid answer to your Docker question. And I do that as well as help out on Stack Overflow and the Docker forums and stuff like that.
And you also have some YouTube videos, which we'll put in the show notes, and you have a Udemy course on Docker, which we'll put in there too. So,
yes, I have a Docker mastery course and a Docker swarm course, and I'm now, I think I mentioned earlier, we've now got 43 students. I'm extremely excited about that, all in less than a year. So if you ever wondered whether Docker was fever pitch, take me, the guy doesn't know how to make a course on the internet, and a year later, there's 43,000 people that have paid for it. And it's clear to me that there's definitely a desire out there for people to want to try out this technology. And so if you go to bretfisher.com, you get $10 coupons. Each course would cost you $10 with the best coupon on that website. So thank you.
Wow, cool. Well, thanks so much for coming on the CF Live podcast today, Bret.
Thank you so much. This was great. I'm glad to be here.